concrete is such an important material. It provides so much key infrastructure for, quality of life in the developed world at the moment, and as we go forward, it's needed more and more in sort of Africa, Southeast Asia. And a world without concrete is simply unimaginable, but the emissions need to be sorted.
Hello everyone, and welcome to Futurex, a podcast by Martin Hearn, Event Director at Futurebuild, and co-host Dr. Oliver Jones, Research Director at Ryder Architecture. Futurex will bring together some of the brightest minds and some of the most disruptive thinkers and innovators to transform the construction industry and build a Futurex community of like-minded people that can begin to make a real change. We really hope you enjoy the series.
Hello and welcome to Futurex. I'm Martin Hearn, Event Director of Futurebuild, once again joined by my co-host, Dr. Oliver Jones at Ryder Architecture. Oliver, this week we're talking all things concrete.
Indeed we are. And I think one of the things that we've talked about quite a lot between the two of us is there's so much action going on in this concrete space.
And absolutely. And I think it needs to, we can't get away from the fact that cement industry is responsible for, almost 8% of all human CO2 emissions. So a huge contributor. But as an industry, we use it so much and it's integral to our infrastructure projects, all of our major builds. So, there's really that search is on at the moment for the Holy Grail. Can we find a truly net zero concrete?
There's a lot of innovation in this space. We've showcased and talked to so many people that are working in this space as well. And Futurebuild showcases even more people that are really active in this low carbon, carbon neutral concrete space. I think one of the things is, as you say, what is the Holy Grail? Well, for me, the Holy Grail in this space is something that's doesn't deviate too much from our traditional processes, and something that is easily sourced and doesn't require an awful lot of additional expensive processes to achieve that carbon neutrality in concrete. Essentially, we have to replace cement and Portland cement. So it was fantastic to speak with the guys at Seratech and Mike Cook and Barney and Sam. I think unbelievable chats.
It's another example, isn't it? I think of a chemist, an engineer, and then they've got Mike Cook over there from Bureau Happold as well. Of industry, sort of the knowledge and the black book that he has coming together to really, excel this amazing new technology that they've.
Well, totally. So you've got this youth, you've got this hunger to change things. You've got the engineering mindset coming in. You've got a fantastic collaboration with a chemist, and then you've got the industry insight. That's something that we usually bring to the table with the advanced startups that we work with. And it's phenomenal that Mike's in a position at Imperial College where he can start to have that effect and assist with accelerating these startups down the line. So, I was amazed to hear from the guys at Seratech. I think they've got a real groundbreaking product waiting in the wings here, and I for one can't wait until we start trialing it.
One is just you put it in the category of another no-brainer. Really, it's almost amazing it's hasn't been adopted already. It's got the scalability, as you said. It's not reinventing the wheel. It's optimizing an existing product. So there's no reason really why this can't be the scalable solution now.
Absolutely. And to top it all off, they named it after me, which is phenomenal. So
well, let's bring them on and we'll find out more.
Right, guys. Well, we're joined by three people today, and really, really happy to introduce Seratech. And Mike, I guess you're the first person to say hello to. We always start by asking people for a bit of a potted history of their journey. So, Mike, do you want to kick us off?
Yeah, sure. Right, I'm the oldest guy in the room, I suspect. I've got a long journey. I'd better make it quick. I'm a structural engineer. I joined, my career started back in the 70s with a quick bout at Arup. And then when Bureau Happold got set up, I became a graduate employee at Bureau Happold, structural engineers down in Bath. And I actually was there right the way through for my career. As Bureau Happold grew, I grew. So I've been involved in a lot of quite interesting and quite weird, in some cases, projects as a structural engineer. Ultimately, by the time I'd come towards the end of my time at Bureau Happold, I became chairman of it, and it was a 2,000-person firm. So it was a really nice journey, if you like, a startup that I joined as a young student that became quite a significant practice that those of us there were pretty proud of. As a structural engineer, of course, I've discovered, increasingly towards the end of my career, how significant a carbon impact we'd been having. Every time I put a bit of concrete in the ground, suddenly I realized I was doing as much harm as I was doing good. So I was delighted when, as a result of teaching at Imperial College, I came across Sam and Barney and wanted to do all I could to help them with their idea of decarbonising concrete. So I've had a bit of an epiphany in the last few years.
Excellent. Well, I guess that's a fantastic link, Mike, through to Sam and Barney. Sam, do you want to give us your rundown, mate?
Yeah, cheers. So I'm also a sort of a structural engineer by background. That's what I did in my degree. But while I was doing that, I felt that I couldn't really go into sort of the day-to-day structural and structural design sort of job. That wasn't really for me. So I had a sort of a little look at contracting. I had some great fun there, and then thought I'd also just try my hands at research. So I started a PhD at Imperial College back in 2017. Looking at sort of sustainable cement and concrete technologies. It was weird, I'd fallen in love with concrete more than any sane person should. But its impact on the environment is so huge that to have the opportunity to work and try and mitigate some of these emissions is such a huge challenge and a great thing to be involved in. And it was while at Imperial I met Barney.
And therein lies Barney's intro. Barney, mate, step on up.
Yeah, so I sort of a running joke for Sam and myself is that our intros are essentially the same. We're basically in the same position. Quite literally, he's about 4 meters to my left. But my background is slightly different. So my undergraduate degree was in chemistry. So I sort of ended up taking a more material science approach, and I was fortunate enough to land a PhD here at Imperial. And then, fortunate further to end up sitting next to Sam, where our work has sort of coalesced and formed into Seratech along the way.
So we'll probably stick with you for a minute, Barney. Can you give us just a bit of an intro to Seratech? Tell us what it is and what it's about.
Yeah, well, I guess the headline is that Seratech can deliver zero carbon concrete. I mean, there's more to it than that, I suppose. But I mean, the first thing to note is that we've done this in a way where the concrete is 90% still concrete. It's still got sand, it's still got aggregate, water, Portland cement. It looks like concrete, behaves like concrete, but it's this last 10% that we produce, and it's this last 10% that ends up making it carbon neutral overall. We wanted people to be able to use concrete as the material that we build everything out of. I mean, concrete is an amazing material. As Sam said, he fell in love with it. I've ended up doing the same thing. I think it's one of these sort of amazing things that goes totally unnoticed by most people. And then you sit down and you look around and you go, my God, this is amazing. We've just built so much infrastructure, and so much of the world is dependent on it. And we need to be able to keep that going. So we sat down with industry and said, what if you were to use a zero carbon concrete, if you were going to move in any direction, what direction would that be? And that has been at the center of all of our R&D. So the material has no real impact on sort of things like fresh properties, and it looks like concrete. The guys on the site would never know they're using a different material, but at the end of the day, it's zero carbon impact infrastructure, and like Sam said, it's a great challenge. I think there's a lot of demand. People want to be using that.
So can you give us a little flavor, Barney, of how it's zero carbon? And we'll probably come back around to you for a bit more product detail after a few more.
Yes. So I guess as a starting point, most of the CO2 that's associated with concrete is really associated with the cement itself. That's, what it is. It was upwards of, I guess, 90% of all of the carbon in the concrete is from the cement. And that's through the calcining of limestone that churns off a load of CO2, and also getting it up to the 1400 degrees that you need to actually make the clinker itself. That obviously requires a lot of fuel. So that's the bit that you need to change in the concrete to have an impact on the carbon. And industry do that at the moment. You know, that's what supplementary cementitious materials, SCMs, they see a lot of use. So things like fly ash from the coal industry and blast furnace slag from steel. And essentially they're just used to partially replace some of the cement. And because they're waste products, they have no CO2. So if you sort of cut your cement content by 30%, your overall emissions are cut by about 30% as well. And you can argue whether or not these waste materials are actually sort of co-materials and should have some sort of carbon associated with them. But in essence, that's what industry is doing. And we took a very similar approach. We've engineered our own SCM, so we don't get it as a waste product. We are specifically in the lab making this stuff. And the way we make it sequesters industrial waste CO2. So rather than emit CO2 in the production of something, we consume it. And then these negative emissions can offset the emissions of the cement. So rather than cutting the cement with something that has zero carbon, we're blending the cement with something that has negative carbon. And our material is about as twice as carbon negative as cement is carbon positive. So it's kind of like a 65-35, 2-to-1 blend, and you end up with a neutral cement overall.
We'll be coming back around to dive into some of those secrets of
Sure,
Seratech,
yes.
Seratech process and formula shortly, Barney. So just jumping back to Sam, you said you guys started in 2017, or you started in 2017. I mean, this is a really rapid sort of process, really, isn't it? I mean, what kind of challenges have you faced trying to set up a startup? Did you initially envisage it as a startup, or just tell us a bit about that process, Sam?
No, so it was, I started my PhD in 2017. Barney started his in 2018. And then I guess this was a product of COVID, probably. So we started really doing this research sort of late 2020. None of the pubs were open, so we thought we'd sit here and do some more work instead. And it was just sort of a discussion about our research, sort of how they overlapped. And originally we found this sort of nice little niche. So Barney's PhD is about sort of making materials, essentially. And I thought, we could use one, as the supplementary cementitious material that he was just talking about. And when we started, this was very much going to be sort of a brief academic exercise, do a few tests, write an academic paper, and then we leave it. But it was as we started doing the tests, the properties of the concrete, and we sort of go, hold on, this works way better than we expected it to. So then we sort of got the university a bit more involved, so started looking at the IP through them. So then that was sort of most of 2021 really was a little bit of optimization, lots of communicating with the industry, as Barney was talking about, really finding out exactly what they want from a material and how we would make it, useful and usable. So yeah, so that was 2021, and then but at the start of this year is when things have sort of really started to kick off. So we filed our patent application in January, and then we started getting grant funding from a range of sources through the university and externally to continue the development. So since then, we've been able to expand the team. So in addition to the three of us here, we've got sort of some academic advisors who are very heavily involved, and 3 or 4 more researchers working with us in the lab. And then we're just starting to expand our commercial team as well. So in terms of challenges, fair to say it's not been completely plain sailing all the way. I think predominantly sort of technical challenges. We come from very technical backgrounds, I guess, but you've got Barney as a chemist, myself as an engineer, and there's this sort of weird, I guess, the chemical engineering bit in between. So whilst Barney's great at designing the chemical process, and I'm not bad at putting the material in a cement and making a nice concrete out of it, sort of the scaling up that goes with the chemical engineering has been a great challenge for us. How do you go from, we've been making sort of a few grams of this material at a time in a little beaker on a hot plate in the lab, but a few grams of a cementitious material are not much use. You can't build houses out of it. So we scaled up a little bit in our labs now. We're at the sort of tens of kilogram scale, just as I would quote, just bigger beakers. But really, it's still a batch process and all of that. It's taking this to sort of the next step of a continuous process integrated with a CO2 flue somewhere in industry. That sort of has been a big challenge and continues to be a big challenge for us, really. We're very fortunate that because we're part of the university here, we've got our fantastic chemical engineering department who we've been working with quite closely to help us sort of, go through the next couple of steps with this. But then it's more about sort of looking outwards to the big, engineering design contractors for processes and these sorts of things.
And I suppose, Mike, that's where they're very privileged to have you on board, which is, you can get that into the industry, or at least get the industry feedback. And what's that been like so far?
Well, in a way, yes, it's that's what I see. I see my role as helping Sam and Barney get this out there in what is a complicated industry, a multi-layered kind of industry. So it feels to me that we need as many people who should be interested in this to be aware of it and become interested in it. And I've been helping Sam and Barney, get that visibility. And across, pretty much everyone we speak to, once they give us the time of day, and especially those that understand the construction industry, understand cement and the use of it, the making of it, are pretty interested, somewhere between pretty interested and extremely interested. And maybe the funders who are not used to this kind of innovation, which needs to bury itself deep in the heart of an existing heavy-duty, low-margin industry. Maybe the investors are slightly more, whoa, this is a little bit unusual for us. We like nice, clean, new things, shiny things that we can safely predict how much money we're going to make. So maybe one of the bigger challenges is we're trying to get something that isn't the obvious thing for investors to just throw their money at. But yeah, we've been working with the institutions, with firms of consulting engineers, getting all the professional side of things to start to see that there's a glimmer of light at the end of the tunnel, that there might be a way that they could continue to use cement and concrete and do it in a way that isn't going to damage the planet, damage their own professional credentials, and go against their emerging plans for becoming net zero designers of buildings and so on. And the same then goes for developers. And then when you get into the construction and the cement industry, we've been talking to various firms across that. They've all started their own internal research as to how to decarbonize the cement making processes. We don't find anyone who's really approached it in the way that we have here at Imperial. And that's in a way encouraging, but possibly increases the amount of, if there is any skepticism, it increases a certain amount of skepticism, because how can it be a good idea? We haven't come up with it ourselves, and I'm sorry, but we just did, and you were stuck with doing it the way you were doing it, or something. So, but they're interested, they're talking to us, and I think in a way I'm a fairly impatient sort of person. I want to see this happen as fast as it possibly can, because we have a very, very serious problem out there. The construction industry really needs to act fast. And what we need to happen in terms of this idea infiltrating into the global cement industry, that's going to take time in itself, just physically, to make those changes in all the different flues, in all the different parts of the industry. So we need to get this thing moving fast. So I want everyone to hear about it as quickly as possible, so that there becomes almost a movement where the professionals, the industry, funders all get on board as quickly as possible.
I think what you've got in your, to your advantage is that the concrete industry are really, there's a huge amount of innovation now coming out of that space. They've got clear route maps and roadmaps to go into net zero, and there's a big industry push to do that as well. What do you see the next year, next 12, 18 months playing out like for you?
We want to get these ideas out of the lab into practice, but it doesn't have to be at big scale. So we want to find collaborators, they may not even be in the cement industry, who we can work with to develop a small pilot to, in a way, give more confidence that the ideas will bear fruit, and to start to produce some of our products at a larger scale as well. Not at mega scale, we're not going to make big bucks out of it, but start to really build the confidence. Because I think while something is still, even if it's in a vat in a laboratory, it doesn't smell of industry. People feel it still looks risky. So we've got to get out there into industry. It might be working with a brewer or something. We're talking about a very interested brewer in the Midlands who creates CO2. We could use that CO2 into our processes. So we are truly decarbonizing their process. And we will be producing larger amounts of our SCM that Barney spoke of, and also another quite interesting byproduct we haven't touched on yet that can be, we're already proving that it can make very good building materials on it in its own right without any cement. So yeah, in the next year, we really want to get out of the lab into smaller scale industry trials.
So I was just taking a look at some of the notes that you guys kindly provided on your phenomenal project and product. I don't know how much you want to talk about your process and the raw materials involved. Are you guys happy to talk about that? That's phenomenal, because first of all, being very ignorant of the raw materials that you used, I was over the moon to realize that you'd named it after me, which is fantastic. So if you want to tell us a bit more about why you did that, Barney, that would be wonderful, and what it is.
Yeah, sure. So the raw material, or I suppose there are two raw materials for us. One is industrial waste CO2, which we're trying to sequester, but the more important one, and there's a slightly lesser known one, is olivine, which is a magnesium silicate mineral. It's a very specific type of magnesium silicate mineral, but these magnesium silicates in general, some people would know them as basalt or the Earth's crust, of which they make up like 80% or something. These are hyper ubiquitous minerals that come in varying forms. Some are sort of partially weathered or hydrated with some water going in there, but the sort of simplest form of these magnesium silicates is a mineral called olivine. In its perfect gemstone form, it's like lovely little green crystals. Ours doesn't look like that. Obviously, you have a grey powder like everything else in cement, but yeah, so it's just Mg2 SiO4 is our main raw material.
So what do you do with that, Barney?
We weather it, I suppose. So there's a process called enhanced weathering, which is sort of known about in carbon sequestration communities. It's where you can grind up this olivine very fine, so it's quite reactive, and just throw it on a beach. And essentially you transform a magnesium silicate mineral into a magnesium carbonate mineral, sort of swapping out a silica for a carbon dioxide molecule in there, storing the carbon in that way, in mineralization. And what we do is much of a muchness. We are essentially turning this silicate mineral into a carbonate mineral. But as that happens, we found a way to produce a very fine, very reactive silica that is essentially chemically identical largely to materials like fly ashes, especially the silicious ones. So it's no different to what the rock would do on its own, exposed to the atmosphere. We just speed it up using chemicals and a bit of warming here and there, but nothing sort of out of this world in terms of temperatures and pressures. It's all fairly mundane, but it's as far as the process goes, sort of a chemical equation, it's no different just to atmospheric weathering.
It sounds almost too good to be true, and I guess that's coming back to sort of Mike's point earlier, is that you guys have, you've found a phenomenal replacement for Portland cement or fly ash, and actually in your process that you developed, you're sequestering and using a lot of waste CO2 in that process, right in that small summation.
Yeah, absolutely. And I think it's a funny one, because I feel like really what we've done is nothing too revolutionary. I think there were a couple of different ideas floating around. It was like a very easy 4-piece jigsaw puzzle, and all I did was slowly put these 4 pieces together. The independent bits had all been there and understood quite well. such as the use of SEMs in concrete, blended cements and enhanced weathering, all of these different things. And then it's just looking at it in a slightly different way and realizing actually this is so implementable in this specific industry, and the result of doing it in this way, being zero carbon concrete, is so marketable and desirable at the moment, and there's so much drive for that itself. I think there's lots of drive for CCS, carbon sequestration in general, but it can be so broad and diffuse in this sort of great big cloud of action that people are sort of a bit like, oh, that's a bit, I don't get that. Whereas if you can narrow it down the way we were able to, just because of the way our products ended up being, and see it having a perfectly understandable application, I think that's what makes it work so well.
So in terms of the raw material itself, as much as I'd love to believe that olivine was just this gloriously rare, beautiful material, is it? Do you have to mine it? Where do you find it from? Is it abundant? I don't know.
Yeah, so it is found in lots of places all over the world. I mean, there's a large deposits of it in Norway. That's where we're currently getting ours that we use for testing. Probably the largest European producer, and of course it has to be quarried. But cement and concrete is such a large issue. You're not going to find the materials to tackle this issue just sitting around out in the open. So there is some mining that's involved, but that mining is going to be offset by having to produce less Portland cement. So you can reason that one out. And then, olivine is quite popular in terms of carbon sequestration because it's so reactive. So there has been some work done actually on sort of global availability. And there's a fun paper that was talking about a deposit in Oman, which has enough olivine reserve to sequester the cement emissions for 27,000 years or something like that. This stuff is all over the place. So to be sequestering emissions long after I'm gone is.
It sounds phenomenal, and we can't wait to continue the discussions with you guys about how we might be able to co-develop some demonstrators or use you guys in some pilot projects. I think.
Oh yeah, for sure.
Super excited about that moving on from here. But on the topic of pilots and demonstrators, you guys have got something coming up, haven't you?
Yeah, so we're really excited. So we've been working with the design company AKT2 and the contractor Burn Brothers to sort of get our first demonstration event, the first sort of site of our carbon neutral concrete in the real world outside of our little lab. So we're doing a project as part of the London Design Festival in September, and this is sort of showcasing a little concrete wall at the AKT offices in Old Street. And what this really does is it tells the story of sort of cement technologies from quite a few years ago up to sort of current best practices, and then where we're looking to take it in the future. So because it's a sort of a brickwork wall, it's a nice piece by piece thing, and each of these bricks is made of a slightly different concrete. So you've got sort of your very high emission classic Portland cement concretes that we've used for a couple of 100 years, and then sort of some fly ash ones. So like the industry best practice right now. So reducing your emissions by 35%, something like that. And then it sort of moves on to our carbon neutral stuff with no emissions associated with it. And it's been absolutely fantastic working with AKT on this in particular. We first spoke to them back in November last year, and as soon as we did, they were so keen to help. And they've completely driven this project. It's all been they came up with the idea, they led it, and that's fantastic to see. Sort of someone who at the end of the day would be specifying our concretes, for them to be so enthusiastic about it and have such a desire to help us get it to a point where they are able to specify it. And their clients, they want to use it in their buildings, and they really do want to minimize the environmental impacts is massive. So yeah, that's that event is on the 20th of September at their offices. So I think if you go on the London Design Festival website, you'll be able to see it, read about it, and I would encourage people to get a ticket and come.
Brilliant. And we're going to hope to see it at Futurebuild as well in March. So that we'll look forward to that. Can you tell us a little bit about the support that you've had through the years? You know, obviously you've had some good collaborations, but have you been accessing things like the Innovate UK or the government grants or support that way? We hear a lot, you know, from the SMEs and startups. We have the importance of that UKRI support that they're offering at the moment.
Yeah, definitely. Excuse me. So we've had sort of support from a couple of different places, particularly in, you know, the financial aspects. So some of the money sort of through the university, which I guess originated from sort of the classic research councils and all of that. We're exploring sort of bigger money from Innovate UK and sort of bays and things like that at the moment, and we've just put a bid in for a fairly sizable grant, which is again focused on sort of scaling up. And I think that's where government grants are particularly good for that scaling, where you haven't got the technology completely settled yet, so it's very difficult to attract you know, venture capitalist investment or something like that, but where there's clear potential in the idea. So yeah, we're very hopeful for that. And yeah, and then beyond that, just sort of we keep our eye on the funding opportunities all the time.
We spoke, me and Oliver spoke a couple of weeks ago to another startup, Fermilon, and something that I asked them was about if they had to do it all again, what would they do differently? We get a lot of startups sort of asking it, what's the sort of, you know, you seem to be on the cusp now. And so it's those lessons you've learned along the way.
Oh, there are so many and none at the same time. I don't think I would do anything differently particularly. It's been so far fantastically stressful and long hours, and you know, but I think it's all worth it when you see a technology start to come together and you do a few tests. You're a little bit skeptical as to whether or not it's going to work, but then for some reason it just clicks. It's unbelievably rewarding, and you know, it's not a point I thought we'd get to be honest. I thought we'd maybe do a couple of months on it, you know, find a barrier that we couldn't cross, and then that would be that. So maybe no, there's one thing I would do differently. Having got the experiences, I know that it's always going to get more difficult. So enjoy it when it's relatively easy at the start. Get a bit more sleep. These sorts of things.
I've got a question for you all. We'll run down the line with this. I'd love for you guys to sort of give us the sentence that summarizes just the strengths of Seratech, like what, you know, the headlines of the product and what you guys are trying to achieve with it. You know, give us those headlines. We'll run down the line. We'll go with Sam first. No pressure, Sam.
How many of them do I do? Do I just do one and then
give us one and leave the other guys something to play with?
I'll go with the obvious one. I'll just go with carbon neutral. You know, there are lots of different cement technologies out there. Very few can claim to be truly carbon neutral, which is where we need to be.
Mike.
I think that the most important thing is that this is something that can be introduced into a very big part of the construction industry quickly, because it doesn't require a lot of new technologies to be incorporated. It doesn't require a lot of new regulations to deal with a new material. So it's got fantastic potential to move quickly. And I'm very impatient to see it move as quickly as possible. That's a long sentence.
No, it's a good sentence. So we've got it's carbon neutral credentials. We've got rapid scalability. Barney, what are you going to come in on?
I would say, I think one of our biggest strengths is that it's just disruptive enough. I think we're new enough. I mean, if you're being kind, we're inexperienced enough to have the naivety required to have just a different enough angle to notice something that somebody else hadn't noticed. But it's not going to have to change the world to, you know, or the world doesn't have to change to use it. That sort of thing.
Phenomenal. Well, thanks for those for that wrap up, guys. We always end our sessions with our guests, and we might be ending it a couple of minutes prematurely here because we've got three of you. By asking our guests what you would love to see in the future. You know, what kind of future do you want to see? And again, you know, not to put Sam back on the spot, but we'll go in the same order. Sam.
I love concrete. And we're not going to see concrete go anywhere. So the thing for me is it doesn't really matter how we do it, right? Concrete is such an important material. It provides so much key infrastructure for, you know, quality of life in the developed world at the moment, and as we go forward, it's needed more and more in sort of Africa, Southeast Asia. And a world without concrete is simply unimaginable, but the emissions need to be sorted. And it doesn't matter how it happens. I'd love it to be us, obviously. But to any technology out there, if it can do that, if it can be scalable and economic, fantastic. That's all I want to see. Guilt-free concrete everywhere.
Guilt-free concrete, Sam. Mike, what's
Yeah, I think Sam put it really, really well. The difference between Sam and me is I don't love concrete. I love what it can achieve, and it's going to be incredibly hard to wean people away from concrete when there is so much of the world that still needs to improve the quality of people's lives, and concrete and cement really helps speed up the improvement in the quality of lives, the improvement of infrastructure, the improvement of housing, and so on. So knowing that we need, people's lives will depend on concrete for very, very many years in the future. We have to find a way of making it environmentally acceptable. This seems to be a way of doing that, and so I'm very hopeful that in the future we will be able to continue to improve the quality of people's lives in a meaningful way, not in a phony kind of way, just better health, better education, better transportation. And it will not be harming the planet that we're trying to eke out a living on. And that would be a fantastic position. So whatever Seratech can do to help, I'm right behind it.
Barney, you've got your closing point, mate. And tell us about your
vision for the future.
Yeah.
I don't know, flying cars and for Saints to win the Premier League. That'd be nice, I think. But I mean, I think I would maybe for myself move slightly away from concrete and infrastructure if I can. And I think I would love to see all heavy industry, whether it's, I don't know, energy or pharmaceuticals or construction or agriculture, move towards a more circular way of doing things. We've had decades of these industries pumping inert salts out into the sea and stuff, and everyone was fine with that. And these are processes that were invented in the 1700s, and it's like there's so much more we can do, and so many places where we can develop and innovate and have impact and just change the way we do things, because there is scope to do it. And I think we can start here, and if we can start here, that's great. And then if somebody else can take the baton and run with it and do something for their industry that they're interested in, perfect.
So before we say goodbye, that was a phenomenal wrap up of the future there from you three. Before we say goodbye to you guys, how can people find out more about you, and how can people connect with what you're doing?
So through our website, seratechcement.com, please do go on and have a look. It's just in the process of being completely overhauled, so it'll look all nice and shiny and new. Go on there, sign up to our newsletter, which we're soon to release. So it'll be every month or two to get a little bit of an update about sort of what we're doing, who we're working with, and also a bit about the wider cement industry and sustainability as a whole. And then social media as well. You'll find links to that again from our website. So do please have a look. And then at events, Futurebuild definitely in March will be there. Come find us, have a chat. And yeah, that's about it really.
Well, I'll tell you what, Sam, Mike, Barney, thanks so much for your time today. And keep on disrupting, keep on innovating. And hopefully next time we speak to you, you will have named a raw material after Martin. Thanks a lot, guys. See you later.
Thank you.
Absolutely phenomenal insights there from the guys at Seratech. I think Sam's points around guilt-free concrete, I'm taking that one away with me. That this really is a guilt-free concrete. It's carbon neutral, start to finish it, and it uses a phenomenal process that's quite low impact and also utilizes waste CO2. I think Mike's points were even more pertinent on the fact that if we're going to continue to improve people's lives across the world, in the short term anyway, concrete is absolutely necessary. We need it to build critical infrastructure, to rapidly construct buildings in areas that really need them in order to improve people's lives. So there's a really sort of authentic mission about the guys at Seratech, and absolutely love talking to them.
Absolutely. And I think this shows that there is no better time than now to be in a startup, really, in that net zero field of work, because the rapid amount of funding, development, and need is just phenomenal at the moment.
Totally agree. And I can't wait to check back in with them and see how they're getting on.
Absolutely. Well, they're at London Design Festival. We're going to see them at Futurebuild in March as well. If you like this podcast, please share, subscribe, and we'll see you soon with another amazing piece of innovation.
Join our community to stay up to date with all things FutureX. Visit futurebuild.co.uk to sign up. Please also like them and share them to help grow our community. You can subscribe to the podcasts within your favourite podcast platform. Thanks so much for listening, and we hope you'll be back again soon.